All right, Big Ideas Algebra 2, Section 3.3, Completing the Square. So this is going to be a different method to solve quadratic equations, mainly being able to incorporate using your perfect squares and rearranging your quadratic function into vertex form. Remember, we've talked about three different forms of quadratics: standard, vertex, and factored. So we're going to be taking both standard and factored form and rearranging it into vertex form. So previously we've talked about how to solve just using algebra, using square roots. So we're going to go ahead and get these x's by itself, writing our equation, and writing the left side as a factored form. Two numbers that multiply 64 but add to equal -16 are both -8 and -8. Normally you would have taken that 100 and moved it over to the left-hand side, but just for the purpose of this example, we're going to realize what happens when you have the exact same factor twice. So in this one, we have -8 twice. And then when you take the square root of both sides, the square root of 100 is plus or minus 10. And then moving the 8 over to the other side, you have 8 plus 10 and 8 minus 10 as your two equations. And when you separate those, 8 plus 10 is 18, and 8 minus 10 is -2. So your two zeros, or your two solutions, are 18 and -2. When you have that as equal to 0, it's -36. That's just going to have you get the exact same thing. It doesn't matter. So in that past example, x squared minus 16 plus 64, that expression is called a perfect square trinomial. It's a perfect square trinomial because your c term is a perfect square and can be factored so that your factors add together to equal your b. If you are able to factor that and you get the exact same number, that's a perfect square trinomial. So -8 and -8 multiply to get 64, but add to equal -16. Sometimes you need to manipulate your expressions so that you can create your own perfect square trinomial. And to make this process easier, this is called completing the square. So because it's a perfect square trinomial, we're going to complete the square and create our own perfect square trinomial so that the example is just as easy as this last one right here. All right, so we're looking at x squared plus 14x plus c, and we're going to leave that number blank just for the purpose of helping find our perfect square trinomials so that that number can be factored into a perfect square. So you're going to take half of your b. So whatever is in your b position, which in this example is your 14, you're going to divide that by 2. If it's a positive, you keep it positive. If it's a negative, you keep it negative. You take that exact number, divide by 2. Whatever you get from your previous step, you're going to square that number or multiply it by itself. So again, if it was positive, you keep it positive. If it's negative, you keep it negative. But remember, the answer to step number 2 will always be positive because you always get a positive answer when you square a number. Then you're going to replace that with your number in the C position and write that as your perfect square trinomial. So you just created a standard form perfect square trinomial where two numbers that multiply to equal 49 but add to equal 14 are 7 and 7 because you created that square by taking half of your b. You're taking that 7 to move it over, and then when you add those 7 x's together, you get 14, and when you multiply the 7's, you get your 49. So that would be your perfect square trinomial. You can go backwards to factor it and get x plus 7, x plus 7. So now using it into an actual equation where we have to solve. In order to complete the square, normally when we solved quadratics, we moved everything over to one side and set it equal to 0. With this one, however, we want to take what number is in our C position and move it over to the other side because this is not easily factorable. So you want to leave your C blank because remember, we're trying to find a C that creates our perfect square binomial, perfect square trinomial. And it's okay that you have a non-zero number over here. We're going to deal with that later. So you're going to take your b term, which is your negative 10, divide it by 2 to get negative 5. Negative 5 times negative 5 is 25. So 25 is the number that creates the perfect square trinomial. Your 25 is now going to be in your C position. And in order to keep this equation balanced, whatever you do to one side of the equation, you must do to the other. So if you're going to add 25 here, you must add 25 over here to this side as well. So combine like terms on the right-hand side while also completing the square or factoring this number right here. So when you factor, remember that number that you divided by 2, that's always the number that's going to be down here at the bottom. So negative 10 divided by 2 is your negative 5, and that number is going to be squared, which is why it's complete the square. When you combine those, you get 18. Take the square root of both sides to get plus or minus square root of 18. Remember, this is not a perfect square, so we cannot take this and get a whole number. But then we can add 5 to both sides. So your two zeros are 5 plus root 18 and 5 minus root 18. Then you just have to simplify your radical like we did in the last section. So the perfect square that you can take out of this is 9. Square root of 9 is 3, and you're left over with that 2. So you can check this by typing it into a graphing calculator, and notice how your 2 points where they cross the x-axis are decimals. That's where you get this square root of 2, but that's actually what the real number is. So 9.24 is approximately what you're going to get when you have 5 plus 3 times square root of 2. And then the one over on the left, 0.76, is about what you would get when you take 5 minus 3 square root of 2. All right, the difference between this example and what we did previously is that our a now has a non-1 in front of it. So this a has a 3, and there is something different that we're going to have to do with that before we can complete the square. So we first have to divide by that number into everything in the equation. So your 3 needs to be divided into both the 12x, the 15, and then if there is a number over here on the right, you have to divide by everything so that it becomes a 1. Then we're going to take our c, move it over to the right-hand side. Then we're going to go through the process of complete the square. So take your 4, divide by 2, and square it. So 4 divided by 2 is 2. 2 squared is 4. So that 4 is what gets added to both sides of the equation to create your perfect square trinomial on the left and to keep it balanced over on the right-hand side so that the things are still equal. Factor this, you get your x plus 2 squared. Combine like terms and you get your negative 1. Take the square root of both sides, and oh look, we have the square root of negative 1, which we talked about in the last section as a complex number, and you can replace that with your I after you've moved the 2 over to the other side. So negative 2 plus I is one of your solutions, and negative 2 minus I is the other solution, or the 0 where the graph crosses the x-axis. All right, so now rewriting in vertex form. This is just another way, again, to say we're going to complete the square and make sure that it's written in vertex form. So vertex form is the way that you can graph the quadratic equation so that you can easily identify the vertex. So this is standard form. Standard form is a little bit more challenging to find the vertex, and we're going to complete the square by figuring out what is going to create a perfect square trinomial onto both sides of our equation. Well, our b term is a negative 12, so you take your negative 12 divided by 2 to get negative 6. 6 squared is 36, so that is the number that gets added to both sides of the equation. Then you can go ahead and factor this perfect square trinomial into your x minus 6 squared. Then in order to get y by itself, so it's an actual function, you need to move your 36 over here to this 18. So 18 minus 36 is negative 18. So this is now written in vertex form, and your vertex is the coordinate point 6, negative 18. And you can go back into, I think, chapter 1 or 2 in the Big Ideas Algebra 2 that we talked about, vertex form if you need that refresher. Again, you can type this into a graphing calculator and check. That minimum point, since the graph points up, is your vertex, and that is at the point 6, -18. All right, a real life problem. So after a ball is hit, it can be modeled in the following function, -16t squared plus 96t plus 3, where y is your height and t is seconds after the ball is hit. And we need to find the maximum height of the baseball, and then how long did it take for the ball to hit the ground. So first thing we need to do is to kind of understand what the question is asking for us to do, and what does that mean in terms of the specific graph. So we're asked to find the max height of the baseball. Since our A is negative, this graph is going to point down. So if we identify the vertex, that is going to be a maximum. So the max height of the baseball is going to be equal to the y coordinate of our vertex of the equation. The second thing that it's asking is how long does it take for the ball to hit the ground? So as the baseball is being hit and it's going in a quadratic function, reaching a maximum and then coming back down, we need to identify both zeros. The first zero is going to start on the axis, but the second one is going to start somewhere further away from the y-axis. But where that graph then comes back down to get the second zero or solution is going to be how long the ball is in the air. So the first thing that we can do to make it easy is to just write this function in vertex form, identify the vertex, and the y-coordinate is the maximum height. And then when you get your solutions, whatever the non-zero one is, how long the ball takes to hit the ground. So let's first write it in vertex form by completing the square. There is an a in front of our t squared, so we need to get rid of that first by dividing everything by -16. So you can pull that out of your equation, since 96 equally goes into 16. 96 divided by 16 is 6. You can do that. Then when we try to complete the square, we're going to try and find the number that can evenly be factored when you divide -6 and square it to get both sides of your equation. So -6 divided by 2 is -3. -3 squared is a +9. So that +9 is what gets added to both sides of your equation. And since that -16 was something that we pulled out in front, to get multiplied here on the right, we have to also multiply it over here on the left. Remember, everything in algebra, when you deal with one side of the equation, you have to also do the same thing on the opposite to keep everything balanced out. So over here on the left, you can combine like terms by multiplying, and over here on the right, you can factor this quadratic, but again, it's t-3 squared because that was what you get when you divide. Then we're going to add 144 to both sides. 3 plus 144 is 147. So this is now written in vertex form. The coordinates of your vertex are +3 and 147. So the maximum height of the vertex is 147 feet. You could have also done this by in standard form, but I know some of you don't like doing your -b/2a equation and then plugging it back in and having to get your height. So the 3 gives you the axis of symmetry, but the height to get the 147 involves a little bit more algebra. So that with the height being 147 as the max, we now need to find the zeros. So we're going to take our equation that we just wrote in vertex form and just plug in a 0 for the y because that's what we're trying to solve for. Move that 147 over to the left-hand side. Remember, we're trying to get t by itself. Divide by -16, and this is going to give you a decimal. If you want to leave it in fraction form, you can, but since we're dealing with a graph and real number terms, it seems to be okay with decimals. Take the square root of both sides. Remember, plus or minus out in front, and then add your 3. So you have 3 plus square root 9 minus 9.1875, and 3 minus root 9.1875. So this quadratic function remember, is pointing down. So you have a maximum, and you have a 0 on one side and a 0 on another side. Obviously, the 0 on one side is going to be the starting point and when the ball is hit, and then as it comes down further away from the bat, that is going to be the other 0 that we're trying to actually find. So that means when you're typing in the -1, the -0.03 doesn't mean anything because that's either your starting point or maybe the ball just passed the plate a little bit, but that's your starting point of where the ball is hit. And then you need to find the +1, so 3 plus square root of 9.1875 is approximately 6 seconds for the ball to hit the ground after it reaches 147 feet maximum. Again, you can always check this by typing it into your graphing calculator to identify what your maximum value is at 147. And then this 0 over here on the right is the one that we're identifying that's about 6 seconds.